Just like carbon fluxes in streams are similar to soils, lake carbon fluxes are similar to streams and soils, but again, have some slight differences. Decomposition in lakes is faster than in streams or on land because of the high litter quality of algae. So again, just like in soils, litter quality is important, except with algae, you never really have low litter quality. So you don't have those compounds like wood or lignin that's produced in plants being produced in lakes. And as a consequence, it's like a terrestrial system that doesn't have any low quality plants. So if you want to think about decomposition and what the constraints are on decomposition, essentially you have fewer yucky leaves. In addition, lakes work a lot more like grasslands than they do anything else, grasslands that are heavily grazed, because for all intents and purposes, a lot of the respiration that occurs in lakes occurs due to grazers. So very little of the organic matter in a lake actually enters a decomposition cycle, at least when you compare it to terrestrial systems. So you have a lot more grazing, and decomposition has a lot less importance in lakes than it does in streams or in the soil system. Now, one thing that's similar to terrestrial systems is that you can think of the production that occurs in the top of a lake like leaves. And these leaves are going to fall and then become buried in the sediments. So in this case, this would be like the top of a canopy, and then leaves fall down and hit the soil surface. Except these leaves are really good to eat. There's no wood, and as they fall down, you have grazers that are here that are going to get to the leaves before they fall, because they fall really slowly. Once those leaves actually do hit the soil surface, there often isn't much decomposition that happens, because the soil surface is anoxic in many cases. So there's not much oxygen in the sediments. And so in some respects, sediments in lakes are like wetlands. Oxygen levels tend to be relatively low, and you might have a relatively thin layer that has oxygen in it. As a consequence, there's not much decomposition that happens. Let me draw that again. So if this is our lake, and here's our sediment down here, the top part might have oxygen, but this part isn't going to have much oxygen. So some of the processes that we talked about for decomposition in wetlands apply to sediments. And just like you can have methane release from wetlands, you'll have methane release from sediments also. Without the oxygen, the terminal electron acceptor, assuming there's not a lot of nitrate around, for example, often results in the generation of methane. So those sediments can either be anaerobic or aerobic, but by and large, those sediments can be anaerobic, and you can get methane production from those anaerobic sediments. Now, about 15 to 30% of lake decomposition occurs in the sediments. And so that's not a small amount, but again, it's still a relatively low number.